KatieRocci is our next presenter. Katie is a second-year graduate student in the graduate degree program in ecology, specifically within the Department of Soil and Crop Sciences. And Katie knew they wanted to study climate change when they attended a global warming conference in the 6th grade. So here's someone who really knew what they wanted to do very early on. Katie's presentation title is Not All Soil Carbon is Made Equal: Unique Responses of Soil Carbon Components to Human-Induced Environmental Change.
What if I told you one of Earth's most precious resources lies just below our feet? I'm talking about soil. Soil does so much for us. It helps grow our food, it cleans our water, and it even provides a sturdy structure for our buildings. But my favorite thing about soil is that it helps us fight climate change. Carbon is the currency of climate change. When we have more carbon in the air, it warms the environment. Luckily, we can store carbon in the soil for tens of thousands of years. And so storing carbon in the soil is a good way to fight climate change. Unfortunately, the carbon in the soil is not safe. Human-induced changes in the environment can destabilize this carbon and release it back to the air. One of the most concerning of these is the increase in global temperatures, also known as atmospheric warming. Scientists have been studying the response of soil carbon to atmospheric warming for 50 years, but we're still not sure of what might happen to it. This might be because we're studying soil carbon too simply. In my lab, we separate soil carbon into two main types: the protected carbon and the unprotected carbon. The protected carbon is formed from nutrient-rich materials that's transformed by bugs in the soil into a sticky carbon that sticks on particles. This carbon stuck on particles is then protected from further breakdown by the bugs. And so you can think of the protected carbon sort of like your savings account. The carbon there is stored for tens of thousands of years. In contrast, the unprotected carbon is formed from nutrient-poor materials that don't get transformed into the sticky carbon and therefore are freely available for bugs to break down in the soil. So the unprotected carbon is more like your checking account. It turns over pretty quickly, years to decades, and is used for everyday ecosystem production. And so the different properties of these two types of soil carbon might lead to different responses under warming. Scientists study warming by artificially changing the environment. Often this involves putting heat lamps out in forests or grasslands, much like you use heat lamps in restaurants to keep food warm. These heat lamps mimic the warming we expect in the future, and so we can see how soil carbon might change. To specifically study protected versus unprotected carbon, I did a meta-analysis, or a study of studies, where I found the average responses of protected and unprotected carbon to warming from a whole bunch of studies. What we find is that only the unprotected carbon is lost under warming, whereas the protected carbon is unaffected. So systems with a lot of unprotected carbon, like in the Arctic, might be more sensitive to warming than systems with more protected carbon, like in agriculture. And so we can use these two different types of soil carbon to better understand whether soil carbon will help us or hurt us in the fight against climate change.